Yes, welcome to another video on control charts. As a series of control chart videos, we have seen continuous data control charts or variable data control charts, which is XMR, X bar R, and X bar S. We have also seen control charts for binomial distribution, which is your proportion chart, and NP chart, which is number of defectives, chart drawn on number of defectives as well as chart drawn on proportion. Now, attribute chart, we are now going to see scenarios where we are going to count the number of defects. There is a change in the terminology. Count the number of defects. It's not defectives, it is defects. So as part of this attribute chart, which is defects, we are going to see in this video about U chart. So let's get into the video. As I was explaining, the scenario is number of defects. So what's the difference between defectives and defect? Let me make it very easy for you to understand. So in my previous example, I was talking about a bulb getting manufactured. So if you manufacture a bulb, take it, put it in the test bench and try to turn it on. If it turns on, it's a good one. If it does not turn on, it's a bad one. So good, bad. A unit can be segregated as a good one or a defective one. The entire unit is defective. But let me give you a different example. So let's say there is a e-publishing company which need to take the page of a book and convert it into a digital version, digital document. As they do it, if there is a spelling mistake in a word, that is considered as one of the defects. Here the page is considered as a unit, and a unit can have 1, 2, 10, 15 spelling mistakes also. So each one is considered as a defect. So then what happens, in a page I can have 100 words. Each of the word is an opportunity for me. On that opportunity I can do a good job or a bad job. If I do a good job, there is no defects. If I do a bad job, there is a defect. So what will happen is, when I do this e-publishing, out of 100 pages I can end up making 450 spelling mistakes also. So that means it cannot be calculated as proportion of defectives. Instead, it need to be calculated as number of defects per unit processed. So that's where the small difference in the calculation and formula comes in. Conceptually, defective is the entire unit is declared defective. Defects, within a given unit I may have multiple opportunities to do a good job or a bad job. In each opportunity I have one scenario where I can make a defect. So that's the difference between the word defective and defects. Now let's come to this particular chart. What we are going to do, we are going to draw a U chart. So U chart is drawn when the data is attribute, within attribute defects. So this defects generally follow Poisson distribution, like how defectives follow binomial distribution, defects follow Poisson distribution. So even in this particular scenario, there is a case of drawing chart for fixed subgroup, and there is a case of drawing chart for varying subgroup. So U chart can be used to draw charts when there is fixed subgroup as well as varying subgroup. So let's understand how does it work. Let's go to the data. So I have my data in this file. So number of pages converted and number of typo errors observed. So this is the data that I have. So number of pages converted is, each day is not same, it's changing. So it is not a fixed subgroup, it's a varying subgroup. So let's start this. There are three formulas here. One is in the case of a fixed subgroup, another one is in the case of a varying subgroup, and third one is, even though if it is in the case of a varying subgroup, how can we use average as a method to arrive at a control limit. So there are three scenarios. Let's understand all three of them. To start with, defect per unit, U, defects per unit. So how do we calculate that? 3 typo errors observed in 30 pages. So this is my defects per unit. So let me calculate that value here. Now I need to calculate average of my U. So I have calculated individual U. Now I have to calculate the average U, for which I say sum of all these data points divided by count of all these data points, and that will give me my U bar, which is average of defects per unit. So this is going to be a straight line. So let me refer this and copy paste it till my last slide or last cell. Now I have to calculate my upper and lower control limits. Sorry, it's upper and lower control limits, not specification limits. Let me change it. Right. So what is the formula? The formula says u bar plus 3 times of square root of u bar divided by n1. So u bar is my average of defects per unit plus 3 times of square root of u bar divided by n1. So n1 is number of samples. So let me close this and hit enter. So I get this value. So this is for the first subgroup where I took 30 samples. So if I copy and paste this formula, it will give me the upper control limit for all the subgroups, and here the denominator is number of samples I picked up. So definitely my control limit is not going to be a straight line. And similarly, I can calculate the lower control limit, and the formula is still the same, but the only thing that I need to do is, as we were doing in the beginning, so to avoid a negative value, we are going to say maximum of 0 or the formula that we are going to calculate, and plus sign will become minus sign for the lower control limit. Right, now I can copy paste this. So what I have done, I have created the u bar, u upper control limit, and u lower control limit. So now if I select my u bar, u upper control limit, u lower control limit, and if I say insert, and if I draw the chart, it will give me my u chart for varying subgroup. This is u chart for varying subgroup, and that's why you can see that the upper control limit is fluctuating. Right. So here is the chart. So we have drawn it in the Excel. Now we will see a scenario where every day I pick up the same number of pages as my sample. I don't pick up the fixed sub, or I don't pick up the varying subgroup. Instead, I pick up the fixed subgroup. So what will happen? The formula is pretty much the same. There is no difference in the formula. The formula is pretty much the same. So first we calculate our u, which is nothing but number of defects and number of pages sampled. So this is individual u. Then this will become my u bar. U bar is nothing but the same formula. So this is my u bar. So this is going to be a straight line. So I'm going to refer this as a straight line. Now my upper and lower control limits. As my subgroup size is not going to change, my upper and lower control limits are not going to fluctuate. So I can go with the same formula that I have used here. So we can just quickly check the formula. Yes. So u bar sample square root, the formula is fine, and same is the case with the lower control limit. Okay. So now what we are going to do is we are going to copy paste this formula till the end, and here, because our number of pages is fixed, we will end up getting the upper and lower control limit, which is not fluctuating. Now what we can do is we can draw the chart by selecting these options, and I can go to graph and I can draw this chart. And now if you see, the chart is drawn, it is the same u chart, which is defects per unit. The y-axis is drawn with defects per unit, and there are certain stages where the defects per page is spiking up. It is very high. So those areas where we need to investigate. So this is how we got our upper and lower control limits for fixed sample size or fixed subgroup and varying subgroup. Now one more formula that we have, which is used in some scenarios, generally not used, but let me explain it. And that scenario is, if we are dealing with varying subgroup, still the control limits can be calculated based on the average of your sample size. So what do we mean by that? Let me take this particular formula. So let me copy this formula and paste it here. So let's adjust the cells. So u bar and u bar. Okay. So the formula is d2, which is u bar, plus 3 times of square root of u bar divided by n. So instead of dividing it with n, we have to divide it with average of n. That's a small difference in this formula. Average of these values. So to make sure that the cells are freezed, I am adding a dollar symbol to the cells so that the cells are freezed. So this is when you know that your subgroup is varying, however you want your control limits to be fixed. So instead of dividing it with individual sample size, I divide with the average of sample size. That's how I reached this particular value. So let me close this. And it is pretty much the same formula for the lower control limit. Only difference is, as we always do, we will add a small function here, which is max of 0 or this value, and instead of plus sign we are going to have a minus sign, and we are going to close the brackets. So now what we can do is, for this graph also we can select DPU, which is this column, U bar, which is this column, and your control limits alone will be these columns. I select this, I click on insert graph, I will get this U chart. Just a minute, there is something wrong here, let me quickly check. So we select, this is my U chart, this is my U bar, this is my upper control limit, and this is my lower control limit. I click on insert. Yeah, so here I have the chart, so let me paste it at the bottom. So friends, the formula is designed, the U chart formulas are designed for 3 scenarios. Scenario number 1, you want to draw the chart with varying subgroup sample size with which your control limits will be fluctuating. Second formula is when you have a fixed control limit. And the third chart that I have drawn here is the subgroup size is varying, but still while calculating I would like to go for the average of n and calculate it. So these are the 3 scenarios. As you see here, how to interpret this chart whenever there is a spike in the control limit on the higher side. So what we need to be very careful is the metric that we are dealing with. What is the metric that we are dealing with? Is it defects? It is infection rate? Um, it is a good to have scenario, bad to have scenario. Depending upon that, the spike or troughs of a C chart need to be analyzed, and based on that we need to take action. So let me see how to draw this chart using Minitab. So let me copy this data to Minitab. Let me also copy the other set of data where we have a fixed subgroup. Let me paste it here. So let click on stat control charts, and within control chart control chart, and within control chart I go to attribute data for U chart. The first time I'm going to select typo errors as my chart variable and pages as my subgroup size, and this subgroup is varying. Again I click on U chart options, I go to test, I put a tick mark on all these tests that I have to check for Poisson distribution, for statistical abnormality. So this is about data points going outside the control limits, 9 data points on the same side of the central line, 6 data points all increasing or decreasing, and 14 data points toggling or alternating up and down. So I click OK. I get the same chart that we saw in the Excel file. So let me copy and paste it so that it becomes easy for us to compare. So let me copy this graph, take it to the Excel file, paste it here. So now what we can do is we can click on stats, control charts for attribute data, U chart. This time I select typo error 1 and I select pages underscore 1. So my U chart options will still be checked. Test will still be checked. I click OK and I click OK. I get a U chart where my control limits are fixed and it is not fluctuating. Right? Okay. So friends, let me quickly summarize it for you. A U chart is a attribute control chart drawn on scenarios where we are dealing with Poisson distribution. And by Poisson distribution, what do we mean? We are counting the number of defects. In each unit, I will have multiple opportunities to do a good job or a bad job. That's why we call it opportunity. So the example I gave is e-publishing, but you can think about any other example from your process. A unit is getting produced, but within that unit, I have multiple opportunities to do a good job or a bad job. Then what we will have is we can inspect 10 units, but we can end up with 15 defects. It's not defective, it is defects. That means defective means the entire unit is called bad. Defects means within the unit I have 1, 2, 5 number of defects. So then what we are going to plot in a U chart is your Y axis in U chart is DPU, defects per unit. So that's what we calculate in this column, defects per unit. Then we calculate the average defects per unit. And after calculating average defects per unit, we calculate upper control limit and lower control limit for the U chart. As we do it, there are three scenarios. One is varying subgroup size. So there is a formula for it, and that's a formula that you see here. The other one is fixed subgroup size. That's a formula that you see here. And the third one is, even though it is a varying subgroup size, you can still apply the average formula on that and you can calculate your upper and lower control limit. The same graph I have also shown how to draw it in Minitab. Hope this video was useful for you to understand under what circumstances you will draw U chart, and when you decide to draw U chart, what is the formula to draw your center line, upper control limit and lower control limit, and how the same chart can be drawn in Minitab. Thanks for your time. Thanks for watching. See you in another video related to control charts, Minitab tutorials or quality management videos. For more such videos, please subscribe to our channel. Thank you.